We continue working on properties of Laplace transform. Let f of s be Laplace transform of f, that is integral 0 to infinity e to a negative ts f of t dt. If I want to take the derivative function capital F with respect to s, I will take derivative with respect to s of that integral, which is written right here, so integral 0 to infinity e to a negative ts f of t dt. From the advanced calculus, we can, using some information from advanced calculus, we can switch order of integration and differentiation. Assuming that function f is continuous and behaves pretty nice. So, and now we write the derivative of inside e to a negative ts f of t. Derivative inside function is not difficult to find, so we're going to have negative t e to a negative ts f of t dt, an integral from 0 to plus infinity. We'll rewrite that, take minus outside, e to a negative ts f of t times t dt from 0 to plus infinity, and we recognize this one as minus Laplace transform of this function, which is t f of t. So what we've got is Laplace transform of t times function f equals negative df ds, where capital F is Laplace transform of original function. In general, we can prove following theorem. Let f of s be Laplace transform of function f where function f is continuous on interval from 0 to infinity and of exponential order alpha. Then for all s bigger than alpha, if we want to find Laplace transform of t to the n times function f, that equals to the nth derivative of f with respect to s multiplied by negative 1 to n. I will do a few examples of Laplace transforms. Start with a simple one. If we want to find Laplace transform of 3t squared minus e to the 2t, we will write as Laplace transform of 3t squared minus Laplace transform of e to the 2t. Take 3 out. Laplace transform of t squared is 2 over s cubed, 2 factorial, minus Laplace transform of e to the 2t is 1 over s minus 2. Simplify that expression a little bit. 3 times 2 factorial 6, 6 over s cubed minus 1 over s minus 2. Let me try to do another example. If I want to take Laplace transform of e to a negative 2t times sine of 2t, I have e to a negative 2t. That means I have to change s into s plus 2, and I will take Laplace transform of sine of 2t. Laplace transform of sine of 2t equals to 2 over s squared plus 2 squared, and I have to change s into s plus 2. All that is left, do a substitution, s into s plus 2, so I'm going to have 2 over s plus 2 squared plus 4. Next example, we want to take Laplace transform of t times sine of t. When we have taken Laplace transform of t times something, we will take the derivative with respect to s of Laplace transform of a function. Don't forget minus. Laplace transform of sine is 1 over s squared plus 1, and we have to take derivative of this expression with respect to s. So it equals to negative s squared plus 1 squared. Derivative of denominator is negative 2s. So final answer is 2s over s squared plus 1 squared. Okay, let's do another example. One will have to take Laplace transform of expression which is multiplied by t. Because we're multiplying by t, which means it's negative derivative with respect to s of function. To find derivative of Laplace transform of sine squared, we rely on a trig formula which will say that sine squared equals to 1 minus cosine of double argument over 2, and we take Laplace transform of that expression, and then we take derivative of that Laplace transform expression. Alright, if we moving on, and we're going to get negative. Laplace transform of this expression is take 1/2 out. Laplace transform of 1 is 1 over s. Laplace transform of cosine of 2t is s over s squared plus 2 squared. And now we take derivative of that expression. Derivative of 1 over s is easy to find. Negative 1 over s squared. Derivative of that fraction is a bit more difficult to find. It equals derivative, we do quotient rule, so 1 times s squared plus 2 squared minus s times 2s. So the expression on top will be, if you look at the top, s squared plus 4 minus 2s squared. So we're going to get negative 1/2, negative 1 over s squared minus s squared plus 2 squared, and 4 minus s squared. Bring negative 1/2 inside, so we're going to have 1 over 2s squared plus 2s squared plus 4, because we take the derivative, don't forget that square here. So 4